Hello everyone, welcome to my second video on decision trees. Hopefully from the first video you saw kind of what decision trees are and what some of the pros and the cons for a business of using decision trees are. In this video we're going to look a little bit about the mechanics of a decision tree, how it kind of works, how it might be laid out on a page, and also how to calculate the expected payoff and the net gain and how businesses might use it to make decisions. So in order to have a decision tree, we need to have a number of options. So for this business, they're deciding whether to increase their productive capacity, whether to advertise, or whether to do nothing and take no action. So our decision tree will always start with a square. A square is what signifies a decision within the decision tree. And as you can see, we've got our three options coming out of that. So increase capacity, advertise, and do nothing. Each one of these decisions has a monetary value attached. As you can see, we've got these numbers in brackets here. So increase capacity is going to cost the business £45,000. To advertise will cost the business £30,000, and doing nothing is free. In some cases, doing nothing may actually be better for the business than taking any action, but we'll come to that later in the video. Okay, so if the business chooses to take one of these options, there is always a possibility that it could be successful or that it could fail. So we have to split these into their possible outcomes. So the split between possibilities is shown by this circle, which is what we call a node. So a node splits between the possible options or the possible outcomes of a decision. So let's look at this increased capacity one. So if we increase capacity and the business has high sales, then the business will receive £80,000. If the business chooses to increase capacity but there are low sales, then the business will receive £50,000. And we have to consider the possibility or the probability of each of these. So as you can see, we have a decimal number here beneath high sales. So the probability of there being high sales is 0.7. The probability of there being low sales is 0.3. You may remember from your GCSE maths that the sum of all probabilities must be 1, and that's the case here. So 0.7 and 0.3 is equal to 1. So if you choose to increase capacity, these are the two possible outcomes, and so they should join up to be 1. Likewise, down here we have a similar thing with advertise at the cost of £30,000. In this case, with advertising, we've got a high sales with a probability of 0.9. We're assuming that the advertising campaign may be relatively successful, with a payoff of £60,000 and a low sales of 0.1, so less likely, with a payoff of £35,000. So, how might a business use this to make a decision? So what we need to do is to consider the expected payoff. Now the expected payoff is essentially the average payoff for every time this decision is to be made. In the real world, the business would only make this decision once. However, if let's say this option was presented to them 100 times with the same probabilities, what would the average payoff be? And that's what the expected payoff is. This number doesn't actually occur in real life, but it's taken into account the probability. If you did this game or made that choice 100 times, what would your average payoff be? So we need to calculate that for our increased capacity. And the way that we do that is using this equation here. So we take the probability of high sales, so 0.7, and we're going to multiply it by the payoff. So the payoff is our £80,000. So we'll start that right here. So 0.7 times £80,000 will give you £56,000. Okay. We also need to consider the probability of there being low sales. So 0.3 multiplied by 50,000. So 0.3 times 50,000 would give you 15,000. Yeah. So that would give us, that's the probability multiplied by the expected value. And then we get, by the payoffs. And then to calculate the expected value, we're going to add them together. So we're going to bring these two numbers together, which is going to give us £71,000. So we assume that if we played this game 100 times, or made this decision 100 times, on average, our payoff would be £71,000. Right, we also need to consider this for advertise. So 0.9 times £60,000 would give you £54,000, and then 0.1 times £35,000 would give you 3,500, and we're going to add the two together, which would give us 57,500. So that's pound sign. Yeah. So if we were just to consider the expected values and the probable payoffs, we would expect this business to choose increased capacity, because the monetary payoff of taking this on average is much higher than that of advertise. However, there is something that the expected payoff doesn't consider, or the expected value doesn't consider, and that's the costs of the project. So increased capacity has a cost of £45,000, advertise has a cost of £30,000. So after we take that off, we get a thing called the net gain. So, so the net gain equals the expected payoff minus the cost. So in this case over here, we're going to move this £71,000 over here. Yeah. And we're going to take away our £45,000, which is going to leave us with £26,000 from that choice. Meanwhile, over here, we're going to take our 57500, and we're going to take away the £30,000 that it cost us to advertise. So in this case, it's going to equal £27,000, or £27,500. Yeah. So this is our net gain. So taking into account the costs, taking into account the risks of failure, this is what we think the business would take home on average. In this case, advertise is £1,500 much more profitable than the £26,000, and so we would expect the business to choose advertise on average. As I've mentioned previously, it's important to consider that these numbers wouldn't actually happen. This is like an average. So that's something that managers would have to consider. There are other things that, other problems with the decision trees. These probabilities might take a lot of calculation, or perhaps a more well-resourced or a larger business might have the ability to calculate these more accurately than perhaps a small enterprise. So there are questions as to whether a decision tree would be applicable for all businesses. Furthermore, a decision tree is much more effective when you've got lots of quantitative data, when you can break down everything that's given and turn it into numbers which can then be applied to the decision tree. If you've got lots of qualitative data, it will be significantly less applicable. Anyway, so yeah, your expected payoff is your probability plus your payoff, adds your probability plus your payoff, adding them together, so coming back round to £26,000 here for increased capacity, and 57,500 for advertise, and then your net gain is taking away the costs from that, which gives you the final average gain from a specific decision. Anyway, I hope that's been helpful to you. Yeah, see you next time.